So far in math, you've seen two types of graphing. The first type is just a number line only, which is just one dimension. And in this one dimension, when you're given a point to plot, it's just one number. Say we want to plot 2. And if it's positive, we count from 0 2 spaces to the right. Or if it had been a -2, we count from 0 2 spaces to the left. So positive means go to the right, negative means go to the left. Then we learned that we can make a two-dimensional plane with two number lines. We have the x-axis, which is a number line, and the y-axis, which is a number line. So the x-axis is where you go left or right, and the y-axis is where you go up or down. And this time we need a coordinate with two parts. We need an x part and a y part. So if we had -3, 1, we would start in the center and go left 3, up 1, and plot the point. So this time when we're doing 2, we start from the center originally to go left 3, but then when we do the y part, we just go parallel to the y-axis. We don't count from the center and go up 1, we count parallel to it. Now we're going to see what it's like to graph in 3 dimensions. So when there's 3 dimensions, it adds a third number line. We still have our x-axis and our y-axis. Note they're going in different directions now. And then the z-axis is going up and down. You have to imagine that the xy area is actually a flat piece of paper. And if you poked a pencil through, the pencil would actually be going up in the air or down below the piece of paper. So now we need 3 coordinates. We need an x piece, a y piece, and a z piece. And each of these pieces now are going to go in different directions. We're used to starting left or right. This time the x tells us whether we go forward or back. Notice it's in a different direction. So for the x part, positive is going to tell us to go forward. Negative will tell us to go back. For the y piece, now the y piece is our left and right. So positive will tell us to go to the right, and negative will tell us to go to the left. And then our z piece adds our new dimension. Now we'd go up in the air or down below the piece of paper. So positive will tell us to go up, and negative will tell us to go down. And it's always in this alphabetical order. It always goes x first, then y, then z. So if we just want to describe, the first type of question is just about describing the location of the point to make sure we know which direction we're going. We would look at our x value, +1, and since it's positive, we would go forward 1 space. I think in the answer key it's usually written as 1 forward. So I'm going to say 1 forward. Next came the y value. Y value says left or right. Since it's negative, we'll go 4 left. So instead of writing -4, it's 4 because the negative is telling us to go left. And then the 3 is in the z spot. That tells us if we're positive to go 3 up. So that's the answer to this question. 1 forward, 4 left, 3 up. We're just trying to make sure we know what directions should we go if we were going to graph this point. For example 2, you'll notice there's a 0. When you have a 0 as part of your point, that means you don't go forward or backwards. It's in the x spot. We're not going forward, we're not going backwards, so we actually skip that one and move on to the y spot. Negative tells us to go 2 left. And then our last number tells us to go up or down. Positive will tell us to go 1 up. So now let's actually plot a point. We want to write the coordinates of this point. So when you're plotting a point on this 3-dimensional system, we usually draw arrows to show where it's located. If you just draw a dot, it's really hard to tell where that's located. When you're trying to draw a 3-dimensional thing on a 2-dimensional surface, it's really hard to look at. So we actually include arrows that tell you what distance you're traveling on each axis. So the x-axis, we started at center and we're going back, and we can see there was one mark here and a second, so we went back 2 spaces. So back 2 means -2. That means A and B are out of the running. We want to start with a -2. From there, we're going parallel to the y-axis. When we go left, it's like we're traveling along the y-axis. If you imagined moving it forward, you can see it goes left 4 spaces. That matches up to each other, and so that's the distance we're traveling. So we don't need to find the z. We know it's 3, but we could also look as it goes up 3. You always have to imagine putting that same line. I'm going to actually drag the line this time because it's harder. The z is the hardest one to tell. Nope, I don't want to drag the whole graph. Maybe I will have to. I'm going to have to drag the whole graph. I wanted to drag the line. Oh, maybe we'll just move the whole thing over. Now we'll drag the line. If we place it on the z, you can see that is going up 3 spaces. Usually it's easy enough to tell from the points without needing to drag it around, as long as you start from the center and count, where's your x going, where's your y going. So our answer is D, because we went back 2 spaces, left 4, then up 3. The final question, or type of question you'll see on the assignment, is which graph shows the point plotted correctly? It will give you a point, and you have to say which picture matches that. So it's important to know what directions are we going. X value is -1. That tells us to go 1 back. Y value is positive, so that means go right 2, so 2 to the right. And the z value is -4. That means go down 4. So now we just count. If we start at the center and we go 1 back, well, we're already just not even there on A. Let's try B. B, we go 1 back. That's still, B is going forward instead of backwards. C, 1 back again is the wrong direction. It's going forwards. And D is the only one where we go 1 back, and then we can check the rest. 2 to the right, 4 spaces down. So that's our point plotted in 3 dimensions. And that's the most basic type of graphing in 3 dimensions. There's actually a lot of useful graphing things you can do, where you graph entire shapes and entire figures in this 3-dimensional plane, which makes it more useful because a lot of the time we're working in a 3D world because that's what we live in. So that's why we even learn this. We've got to start with the basics, but it can be then used later on to graph entire shapes.